Good evening, students. Today's lecture, the sampling technique we are going to see. Before seeing the sampling technique, just the preview of the sampling and sampling process. So we all know that sampling is a very complex and technical process we use in the research. By doing sampling, we are going to draw the conclusion and make generalization over the population. So that we know already. And you know what is the definition of population? So population is the total category of person or object that meets the criteria for study established. So this is the population definition, and we know that the population can be defined in two ways. One is target population. So target population are those population which meets the sampling criteria, and accessible population are the portion of the target population which the researcher has reasonable access. So next we want to know what is the meaning of generalization. Generalization means extending the findings from the sample under study to the larger population. For example, in a class, one student is good, so we extend our finding to the larger group. In a class, for example, that student is good, so all the class in the student will be good. So this is the process of extending the finding from the sample to the larger population. That is called generalization. So how we select the sample? Sample sometimes selected either by means of random method or non-random method, and sample is a portion of the defined population. It is the subset of the population of interest, and each sample is called element. So elements are the single individual of the whole sample. And what is sampling? It is the process of selecting the portion of the population to represent to entire population. So this already we have discussed, and mostly in nursing research, the element can be human beings most of the times. But generally in research, the element can be a place, or it can be object, or it can be any documents, etc. Now the next is what is sampling frame? That also we have seen. Sampling frame consists of a list of items from which the sample to be drawn. If the population can be two types. One is finite population, another one is infinite population. So the finite population which we can easily count, and infinite population are those which we cannot count. So mostly um the sampling frame having the population, each and every samples details. Okay, so that example is telephone directory and name list of the students, voter list, and attendance register of patient visiting a hospital. So these are the sampling frames. And what we want to see next is sampling designs. So sampling design is a definite plan. This plan tells how we are going to select the sample by using the sampling frame. So by using sampling frame, how we are going to select the sample for our study. So sampling design is the technique or the procedure the researcher adapt in selecting some sampling units from which inferences about the population is drawn. By using the sample, we are going to understand about population. By doing the study, we are going to make the inference. Sampling designs basically classified as probability sampling and non-probability sampling. So next important thing we have seen yesterday, the sampling criteria. So for selecting sample, there are some criteria. These criteria can be divided into inclusion criteria and exclusion criteria. So the inclusion criteria tells who are all will be our samples. Based on that criteria, we are including the samples in our study. The sampling criteria may be defined to make the sample on homogeneous or to control the extraneous variable. The criteria may be broadly defined to ensure a heterogeneous population with a broad range of values of the variables being studied. So why we keep sampling criteria? Sampling criteria is kept to recruit the sample in a uniform way. So the sample should be similar to the population and it should not have much differences among each other. So to make sure our sample is homogeneous, which is having uniformity, so we need a criteria, and this criteria also help the researcher to control the extraneous variables. Already we know the extraneous variables are those variables which cannot be controlled by the researcher. Extraneous variables also known as confounding variable. Okay. Okay. Now let's see the what is the representativeness. The meaning of representativeness. Representativeness means that the sample accessible population and the population are alike in as many as possible. So when every people in the sample, the accessible population, the target population, the population all having similar characteristics as per the sampling criteria, then that sample we can say it is a representative sample. So representativeness should be there whenever we select the sample. Representativeness need to be evaluated in terms of setting. For example, we take sample from the rural areas. So all the sample must live in that particular rural area. That is the representativeness. If you see the characteristics of the subjects, everybody having corona positive case, so that is the characteristic. All the sample in my study must have diabetic mellitus, the blood sugar level between this range to that range. So whoever going beyond that or going below that will not be considered as representative of my study sample. Okay. Next is about what is the sampling bias? Sampling bias refers to the systematic over-representation or under-representation of same segment of the population in terms of a characteristic relevant to the research question. For example, when we take the sample, either we take all the 60 sample, like for example, everybody who have postgraduate qualification, that is over-representation. So we want to have the sample randomly. We want to select some people from illiterate, some people from primary education level, some are in secondary, some comes under higher secondary degree, some people comes in the postgraduate, like that. Don't select in a over representative. For example, every member having the upper class, so don't select like that. What is under representation? Don't select the sample in such a way that everybody have the lower profile, like everybody having primary level of knowledge. Don't select like every member's income is in below poverty line. So that is called under representation. So sample should not have either over representation or under representation. That may leads to error in our result. Okay. Okay. Next, we will see about what are the advantages and disadvantages of sampling. So let's see the advantages first. So when we have sampling, we have economy in our expenditure. So economy in time, and when we have good sample, the scope of research is very good, and sample help to get the accurate results, and we can make our work in a organized and in a convenient way when we have sample. And sample helps to avoid intensive and exhaustive data, and sample also suitable in limiting our resources. Instead of doing the study for a whole population, when we have a good sample, so our resources will be towards that particular small size of sample only. So with sample we can get a good report. These are the advantages of sampling. So the disadvantages of sampling, because of sampling, there is chance of bias. We have seen that under representative of sample, over representative of sample, that we can able to get, that leads to sampling bias. And getting the sample is sometimes very difficult. That also getting a representative sample is very difficult. And next disadvantage is for doing sampling, we need a good knowledge. You must know which type of technique should be adapted for your research, and you must know how to calculate the sample size for your research. These and all needs a good knowledge. And changeability of units. Sometimes the samples may leave the research and they might go. That also leads us to land up in a problem. And next one is impossibility of sampling. Sometimes some samples we never get. For example, now you cannot go and find any cases with smallpox because smallpox is already eradicated in the world. So such cases we cannot find out. So this is about advantages and disadvantages of sampling. Now let's see the very important thing about what are the characteristics of good sample. So the first characteristic, the good sample is one which within restrictions imposed by its size will reproduce the characteristic of the population with the greatest possible accuracy. That means the good sample is the one which must have the representation of the population, and it must be able to reproduce the characteristic of the population with good accuracy. That is the thing. Means very simple, a good sample must be similar to that of population. It must be possible for the researcher to make generalization, the findings with the population very easily, accurately. The next thing is sample should be free from random sampling error. So when we select the sample randomly, we must predetermine the criteria. At the time when we do, that may cause random sampling error. The criteria must be set first itself when you select a sample in a random method, and should not be any substitution of originally selected unit. This yesterday we have discussed. Our sample must have the originality. For example, I do study among nursing students. If I didn't get nursing student, I should not use physiotherapy students or pharmacy students to participate in my research. So that leads to contamination of the sample. And sample should not suffer from incomplete coverage of units selected for the study. For example, the calculated sample size is 400. I must be able to get all the 400 samples. We cannot go with incomplete samples in the study, that we cannot get a accurate and reliable result. When the sampling is incomplete, then that also affect our study result. So these are some of the characteristics of sample. Other characteristics are the should not suffer from incomplete, that we have studied. Relatively small samples properly selected may be much more reliable than large samples poorly selected. When you select the sample, if you select properly a small amount of sample, that is very good to give very accurate and precise result. Instead of selecting a large sample size without following the principles of selecting sample, that is not going to give a good result. While constructing a sample, it is important that you must know the probability, measurable, what we can say. It is important that measurable or knowing the probability, the chances. Okay. Next one is sampling process. This we have seen already. So the sampling process is the technique used in selecting the designated samples from the population. So various steps. First one is define the population. This we have seen yesterday. The second one is specifying the sampling frame. I'm not going detailing into this. Third one is specifying the sampling unit, and the fourth one is specifying the sampling method, and that is whether probability method or non-probability method we are going to specify. The last one is determining the sampling size, and of course the final thing we want to implement the plan for selecting the sample. So these are the various steps in selecting the sample in sampling process. So yesterday we have seen 5 steps. So this is also a sampling process with additional 2 steps. So which one is easy, you can follow that. Now come to today's specific topic about methods of sampling. Sampling methods are classified into two generic types or approaches. First one is probability sampling method. So probability sampling method uses the technique in which the researcher ensures the probability. So probability is equal chance. Probability meaning is equal chance. The each element of the population will be included in the sample. So in probability, we are giving equal importance and equal chance for all the elements in the sample to get selected. So it utilizes some form of random selection, because of which greater confidence can be placed in the representativeness of the sample. So probability sampling method helps the researcher to get greater confidence in the representativeness of the sample. The next one, non-probability sampling method. This method uses non-random methods. There is bias in the selection. There may be lot of bias in the selection. So here we cannot give assurance that every element in the population have chance of getting included in the research. So this method does not assure that equal chance, equal importance is given for the every element in the sample to get selected in the research group. So this is the sampling approach which we are using in the quasi-experimental studies. Sometimes this we are using in the pre-experimental studies. Also we use this in non-experimental researchers. Now let's see each thing in detail. Basically, the types of probability sampling, we have 5 types. Simple random sampling method. Second one is stratified random sampling technique. Third one is systematic random sampling technique. Fourth one is cluster sampling technique. Fifth one is area of sampling or area sampling method. Okay. Now, non-probability sampling technique that have different types. One is convenience sampling technique, also called as accidental sampling technique. Second one is purposive or judgmental sampling technique. Third one is quota sampling technique or snowball sampling technique. Fourth one is event sampling technique. And last one is time sampling technique. So these are the different types of sampling technique. So in today's video, we will see only probability sampling technique. In next video, we will focus on the non-probability sampling methods. So probability sampling method, the first type, first we are going to discuss simple random sampling. This is the most commonly used sampling technique in all the research, particularly in the true experimental research. So in this case, each element in the population has an equal chance of being selected, and that each choice is independent of other. So one of the biggest advantage in simple random sampling technique, every element in the sample is getting equal chance to get selected in the research. And one of the most common technique which we use, like one of the technique of random sample is to be use a random table method. So this we have seen already how to select sample randomly by using a table method. So again, I am not going in detail. In every research book and statistics book, in the back side you can see a random table. So by following that table, we can select the samples randomly. Another technique is picking a chip or picking a lot from the various samples names are written in a box, and from that we are picking the lot, and we include that particular sample in a group, either in experimental group or in control group. So simple random sampling is very easy method, but sometimes when we have very large size, it takes more time. And what is the advantages of this method? What is the disadvantages of this method? Let's see. In simple random sampling technique, all the element in the population have an equal chance of being selected, and it is the very easiest method to apply. And next advantage is most simple to understand. Simple for everyone to follow a simple random sampling technique, and it does not require prior knowledge of the true composition of the population. So this is the advantages of simple random sampling technique. The disadvantages of simple random sampling technique. Sometimes when we don't have the sampling frame and when the samples are not available easily, we cannot do this technique. And another disadvantage is it is going to be a laborious task for the researcher to select sample when we have less time, because when the sample size is going to be larger, it may take more time to select each and every sample. So these are the disadvantages. The next sampling method is systematic random sampling. Systematic random sampling, it is also called as, this method is also known as pseudo simple random samples. Systematic random sampling technique is also called as pseudo simple random sample, as they have properties similar to random sample. So this method is also known as pseudo simple random sample because this sampling technique looks similar like random sampling technique but with some modification. A systematic sample is selected by first listing the population and by choosing a random sample by applying the formula. Like we have the formula k is equal to n by n. So the n represents the total number of population. For example, I have 40,000 people. In that 40,000 people, I want to take only 200 samples. So I applied this formula 40,000 upon 200. So I get 200 as the k value. So every k value, that is every element who is coming in 200 in the population list, will be included in my study. For example, in a village or in a city, 40,000 people are living. In that 40,000 people, I want to take 200 people for my study. So I cannot go and do simple random sampling technique. It takes more time. So I select systematic random sampling method. So I apply this formula. First I should know how many number of population available and how many number I need. So capital N by small n gives the k value. So in the list, the first sample will be number 200. The second sample will be the 400 number. The third sample will be 600 number. Like that it goes. So this is systematic random sampling technique. So what is the stratified random sampling? The next one is stratified random sampling technique. So it is a type of random sampling technique in which the population is first divided into two or more strata or subgroups before sampling process begins. For example, in a college, 400 students are there. So first we divide the students into different strata. For example, we divide the students like those who are coming from village, rural areas, those who come from urban areas, and also we divide in various strata like based on the course they are studying. like GNM students, post basic students, MSc, like that various strata we are dividing. And from that strata, we are going to select the sample by using the random sampling method. Okay. So stratified sampling design subdivide the population into homogeneous subset from which an appropriate number of elements are selected each from each strata. For example, from GNM students, I select 25 samples. From BSc nursing, I select 25 sample. From physiotherapy first year, I select 25 sample. Like that, when we select equal number of sample from sub like subgroups, or we can say from the strata, that is called stratified random sampling technique. So stratum consists of portion of the population. The sampling units of the stratum are similar to each other and are different from numbers of another stratum in the characters that we are going to measure. So this is very simple method. So when we have large number of samples, when everybody have similar characteristics, we make the criteria, and based on that criteria we divide the stratum, and from each stratum we are going to select the sample by using simple random sampling technique. So either you can select proportionately. For example, we have five groups, five strata. In all the strata we can select 20 samples so that we get 100 samples. Or sometimes we can go for non-proportionate selection of sample from each strata. In one strata you are getting 20, in another strata you are getting 30, in another strata you are getting 15. So this is non-equal, that is disproportionate. So this is about stratified random sampling technique. The next one is, so this is the best example, a study to determine the knowledge and attitude of selected women towards menopause and its relationship with selected variables. The strata can be divided into the women's. So the women's are divided into different strata like working women, and those women going for office work, and those women goes for school as school teachers, non-working women. So from each strata, I can select the sample either in a proportionate way or by non-proportionate basis. Proportionate means from each strata we are selecting equal number. A non-proportionate, we select different numbers from each strata. The next method is cluster sampling technique. Cluster sampling technique also comes under probability sampling technique. So here the sampling unit, like each, what we are doing, cluster sampling means random selection of sampling units consisting of population elements. Instead of, for example, I want to do a research in Haryana. So in Haryana, we have different districts. So I am selecting the sample of one particular districts. For example, I want sample from three districts of Haryana. So I don't know which district I want to select. So I go for cluster sampling technique. So in that method, I divide like Karnal district, and I take Panchkula, and I take Rohtak. So this is cluster sampling. So all the elements together comes under one cluster. For example, people living in Karnal comes under one cluster. People living in the Panipat comes under another cluster. So like this, when we select the sample, that type of sampling method is called cluster sampling method. The randomized selection continues through several stages and is then referred as multi-stage sampling. For example, in India, all over India, I want to do a research. So what I will do, first I list down the states. So from that states, I select five states. From that five states, I am selecting five cities in each state, and from each cities I am going to select one college. So like this, when we do that, sampling method is multi-stage sampling technique. So multi-stage method mainly we use when we have cluster sampling technique to be applied in our research. The last one is non-probability sampling. This we will see in the next class. So just conclude with today's lecture. Today we have seen the preview of what is sample population, element, sampling frame, sampling characteristics, advantages, disadvantages, as what is the sampling process and what are the types of sampling methods, and finally we have seen different types of probability sampling technique. In that we have seen simple random sampling and systematic random sampling, stratified random sampling, and cluster sampling technique. So these are the different types of probability or random sampling methods. In tomorrow's lecture, we will see non-probability sampling method. Thanks for watching this video. Take care. Bye bye.